Alright, so we're going to finish talking about our concepts we had listed on that first sheet. The next one is the idea of betweenness. In other words, if someone says this point is between two other points, what does that even mean? Okay, so to be between is going to mean two things. First thing it's going to mean is that all three are collinear. The second is going to be a certain kind of equation. So let me show you what I mean through a small example here. Here's a phrase. How about T is between R and Y. Okay, so from our first discussion, we know that these are all points. Those are capital letters. To be between, first that means that all three of these points I've listed are all on the same line. Collinear means all on the same line. So I'm just going to draw myself a line. Doesn't matter. And you can just draw a segment if you want to. But I'm going to put T first. And then the points R and Y on either side. Doesn't matter which side. I'll put R over here. It didn't tell us which sort of side of R or Y T is on. It doesn't matter. So T is between R and Y. Now if I look at this segment RY, I've got actually three lengths in my picture. I've got RY, I've got RT, and I've got TY. So here's one length, there's another one, and there's this one. Now if T was in between there, that should tell us about something, about the distance from R and the distance from Y. If I was to look at, maybe this was a 2 and this was a 3, that should then make this whole thing a 5, because 2 and 3 makes 5. Or if this was 6 and this was 4, this whole thing should be 10, because 6 and 4 makes 10. In other words, if T is between R and Y, if you add the smaller lengths that T makes with either endpoint, so I'm going to add these lengths together, you had better get that larger one. So anytime you see this word between, what I want you to do is first draw yourself a picture, put that point that's between in the middle, somewhere in the middle, and the other two on either side. Now we don't know if T is exactly in the middle. In other words, we don't know if TR is the same length as TY, but we do know that when you add those lengths together, you should get that whole thing. So I said, first thing you want to do is draw yourself a picture. The second thing I want you to do is write an equation, because a big part of our class is using that algebra, but if we do not set up the correct equation, then our algebra is going to be useless. One of the biggest challenges you all are going to face this year is coming up with the right equation. I know that's annoying because it's basically like working with word problems. But what we need to do is understand these concepts like between. We need to know, what does that mean? So we are really going to focus on definitions and concepts this year. You need to understand those concepts to set up the right algebra. I know you guys are really good at algebra, but this is a geometry class. Algebra is going to be necessary, but that's not really going to be able to, earn you points on a test if you're setting up all of the wrong equations. So how might this work out, like on a homework assignment? All right, here's an example. Okay, so they want us to find the value of x. Now this is a lowercase x, so that tells me it's not a point. And QP. Well, this should be a length. I know that that's a length because it's 2 points next to each other and they haven't put anything above. P, Q, R, okay, those are all points. Those are points because those are capital letters. Here's another length. Or actually, that's the same length described, it's just in terms of a variable. Here's another length. Alright, the keyword in all of this, between. As I mentioned, I want you to do two things anytime you hear that word between. First thing, I want you to draw yourself a picture. So I'm going to put P here, and it's between Q and R. Doesn't matter where I put it, I'll put Q over here and R over there. Now, as I mentioned on that last one, I don't know if QP and PR are the same length, so I'm not going to assume that. We can't just assume a relative size. Okay, the next thing that you want to do is write an equation. If P is between Q and R, I know that QP plus PR equals QR. Because to be between, this equation has to be true. The smaller parts together have to add to the whole one. Alright, so far we haven't done any work, but all we've done is translated this word between in the context of points P, Q, and R into a picture and into an equation. I want you to do that every single time. I guarantee you if you do that, it will make your life so much easier. Oh, okay, so what do these all stand for? They're distances, and they told me some things I can put in place of those distances. For QR, I can put a 22. For PR, I can put 2x squared plus 3x plus 3. So this is PR. And then for QP, I can put x squared plus 1. Okay, so, oh look, a quadratic equation. That's probably why we spend all that time reviewing those equations. We're going to use these a whole lot throughout the year. So let's combine like terms. 3x squared, 3x, and 4 gives me 22. I can take away 22 on both sides. That'll give me negative 18. Okay, so many of you might be tempted to just jump to that quadratic formula, which you're totally allowed to do, but I'm noticing all of these coefficients are divisible by 3. So I'm going to go ahead and just make my life a little bit easier. Oh, now I can try to factor. Alright, let's see. Two numbers that multiply to minus 6 add to positive 1. I'm thinking maybe 2 and 3, and some positive 3 and a minus 2. They multiply to minus 6, add to positive 1. Also, do not forget that equals 0 part. We need to have our equation. You can't just get rid of an equation when we start with 1. So I get two values, negative 3, positive 2. Okay, cool. Many of us are going to want to just stop, or I should say, move on to the next problem. Well, a part of our class is looking at the geometry, turning it into algebra, using that algebra to come up with some stuff, and then making sure that our answers make sense. I want to make sure that these are both acceptable. We said that measurements, or distances in this case, are always supposed to be positive. So when we plug these in, we want to make sure that we get positive numbers. Let's check. QP. If I plug in a minus 3, QP, if I use PEMDAS, that's going to be negative 3 squared, which is a 9, plus 1, that's 10. Okay, so QP is 10. What about PR? We want to make sure that's also positive. Negative 3 squared is 9 times 2, so that's 18. Negative 3 times 3 is a minus 9. And so 9 plus 3 is 12. Okay, so we get two different answers. They wanted us to find QP and the value for x. So x equals minus 3, QP equals 10. There's one answer. Now I want to check x equals 2. Okay, so if x equals a 2, QP is going to be, go back to what that is, 2 squared plus 1, it's going to be 5. And we also want to double check that PR will be positive. Okay, well these are all positive coefficients. If I plug in a positive, I know I'm going to get a positive. So if if x is a 2, QP will be 5. So here I get two different sets of answers, and that's going to happen sometimes. So just be ready for it. Okay, so just to recap, between this, we were able to first draw a picture, then we set up an equation, we solve the equation, and then we make sense that, or we check that the answer we get, or answers we get, make sense. Sometimes you're going to have to throw out one of these. It really just depends. Every situation is just a little bit different. But do check your variables, plug them in, Don't just look at your variable and say, oh, that x is negative, so I'm going to throw it out. Well, sometimes the negative will actually work and the positive won't. It's just different for every single problem, so be really careful. I'm going to stop here, and then the last thing we're going to talk about is how do we find distance on a number line or in the xy plane.